private cloud really is not very different from the kind of data centers that they run today, right? Except that you could essentially offload something like this to an EC2, provided that they have an agreement in place that certain constraints would have to be met by Amazon or whoever the provider is going to be, right? An example constraint could be that I always want machines allocated from the same pool every time I ask for them. I don't want geographic distribution, could be another constraint. There have to be certain security guarantees that are made by the vendor before they gave the machines to us. These are the kind of constraints that would have to be put into an SLA or an agreement with the vendor in order for them to move over. But the fundamental technology behind the notion of a private cloud is not very different from the notion of a cloud in general. However, there is a new and interesting technology called virtual private clouds that is coming in. And this is really a means of extending your own network, your own data center's network as an enterprise to include certain cloud computing resources. So suppose I had a situation in which I had my standard 3-tier architecture or N-tier architecture for applications, enterprise applications, and I wanted to move just the app server tier over because I would be hesitant to give up my database. That's the assumption. I would move the app server tier over, and if I did that, then what I would want is the app server to exist in the same networking environment as the rest of my tiers. Right? To do this, Amazon already has introduced something called the notion of a virtual private cloud, where they create a VPN that includes resources from the cloud environment that they're providing and your own network. And there is security guaranteed within such an environment of data that is being transferred from tier to tier. Right? So this technology is something that I see taking off in a big way, because I think this is being asked for many customers. Cloud metering is a huge area of research, right? So a lot of effort is going into being able to meter at a very fine-grained level the use of cloud computing resources. Now, once that metering comes into play, it's going to be a very easy task to be able to do things like chargeback, because they can tell you exactly where you spent your resources. It's similar to the notion of metering at a very fine-grained level in a building such as this, right? Because there is power being consumed by the data center in this building, there's power being consumed by air conditioning, there's power being consumed by lights, by computers, and so on and so forth. The question is, are we able to separate the power consumption across these different entities? Today we are not, because we're not metering at that level, but we could do that, and that technology is coming into play today in the cloud space of being able to meter resources, usage of resources at a very fine-grained level. If you're needing resources for developing large applications, then certainly I think people are already using cloud resources today, and that's where places like EC2 are earning their revenue. Another role is that of testing. Right? A common scenario is that I build an application today and I test it in a very limited edition of the production environment. So if my production environment is slated to host 10,000 concurrent clients and I need 500 servers to do that, I will not be able to put in 500 servers in the testing scenario. So what I'll do is probably test it with 10 or 20 servers and then extrapolate to say that this is going to perform as I believe it should in a 500 server, 10,000 concurrent client environment. Now we can get around this extrapolation issue because the extrapolation is often very inaccurate. So what people do today is over-provision the production environment, over-provision it for twice or more of what is actually required. Now we can get around this by using a flexible set of resources temporarily rented for the purposes of testing on production scale. And people are doing that. Today already people are doing that. So I believe as far as the role of hosting production environments is concerned, we are still a ways away from seeing that. And there are several issues which still need to be resolved, including that of trust, including that of performance and security, and so on. But in terms of the role of the cloud for testing, I think we're already there. And because the test data can be masked in a way that you do not release any customer information. It could be dummy data, so you don't have these notions of security coming into play during testing, or you could protect against it very easily. So I think for testing and development it's going to happen. For production deployments, it's questionable whether it will happen immediately. we should really separate out the issues of security from those of trust. And there are two formal issues, both of which have to be addressed in their own right. Right? Security concerns with protecting data and protecting access to functionality provided by applications, right? Only allowing authorized access to go through. Now, towards that end, we are actually in a pretty decent shape as far as technology is concerned. We have the technological tools necessary to protect data, right? We can encrypt data even in a database, and all the major database vendors allow you to do that today. You can protect data flowing over a wire through pretty decent encryption means. There are powerful encryption algorithms that are available. However, this comes at a cost of performance, right? The moment you start encrypting data, you are going to pay the price in terms of performance because you have to encrypt and decrypt at both ends, right? Now, we are trying to get around this by trying to provide encryption and decryption in hardware as opposed to doing this in software. Now, when these chips come into play, it will solve the performance issue. And at that time, I believe that we will have the security infrastructure that is necessary to move your applications out to another environment, right? Apart from your own data center. Where today the protection is done by firewalls, by creating a DMZ that is completely isolated from the outside world with very, very limited access, right? But the issue of trust is going to remain, right? A good question is, if a CIO today buys a computer or a server from IBM or HP, how can he trust that machine? How does he not know that the operating system of that machine is malicious, is corrupt, to the point that he's going to take whatever is going to be deployed in that and ship it off to somebody else? We don't know that. Yet, we have established a sense of trust with the provider of this infrastructure to say that I can safely host my applications even though I am controlling it. Now, the human element to some extent has been taken out of the picture here. Now, in the case of cloud computing, not only am I trusting a server that is built by somebody else, but it is also being operated by somebody else in this case. And so, as long as the cloud provider, the cloud vendor, can put up a set of assurances that the operations of this infrastructure leaves no room for a violation of the trust, then I think it will be okay to go there. But those are two separate issues, and we have to deal with them separately.